we go into the topic unit vectors, which we'll use at a later stage, especially for projections of vectors onto others or into other directions, as well as the applications to work when it comes to the dot product and um, moments when it comes to the cross product. The unit vector is a vector that has got magnitude 1. And if you want a unit vector in a particular direction, for instance, if you want a unit vector in the direction of another vector, then the formula is given as that particular vector divided by its length. We need to remember that I, j, and k are unit vectors in the directions of the x-axis, y-axis, and z-axis respectively. Then we can be able to find unit vectors in any direction. So that means what we're trying to say here, unit vectors, they give direction to any vector. Remember, a vector has got both magnitude and direction. So the direction is given by a unit vector. Let's do a few examples. Firstly, we've been given a vector r, and we are asked to find a unit vector in its direction. So the formula is the one that we spoke about, which will be r divided by the length of r. So we write r in the numerator as it is. That means the given vector. And then we use the distance formula to calculate the magnitude or the length of that particular vector. And please check my calculations to see whether I've got everything correct. So the unit vector in the direction of r is given by the answer that we have there. And if you want to check whether you've done your calculations correctly, find the length of the unit vector that you got, and you will see that the answer will be 1. Then we've got number 2. Here we've got a different setup altogether. Yes, we're still looking for the unit vector in the direction of vector AB. But then A has got an initial point 135, which is A, and a terminal point, which is 712. Now, just for ease of calculations, in layman's terms, in order for you to get vector AB, what you do is to subtract the initial point from the terminal point. So that means it should be OB minus OA. As you can see here, it's OB minus OA every time. And then you get vector AB, because we've been told that the unit vector we're supposed to calculate is in the direction of AB. So we need to have vector AB in order for us to be able to do that. And then we use the formula in order for us to get that answer. Please check my calculations and see if we have everything correct. Once again, when you've been given 2 points, an initial point and a terminal point, make sure that when you get the vector AB, it would be the terminal point B minus the initial point A. But if it's vector BA, it means that the initial point is B and the terminal point is A. Please don't forget that. And then we go to number 3. Now, based on number 2, please remember that we're basing everything on number 2. We're asked to find the force F, and we've been given its magnitude. Remember, a force has got both magnitude and direction because it is a vector. So the first thing that we have here, we need to get the direction. And the direction has been given to us by the unit vector in number 2. So our unit vector that we got was that one. And then the force has got both magnitude and direction. So what you'd simply do is to multiply your magnitude to the unit vector and get the vector force. And please don't forget the units that have been given, kilonewtons. Always remember, force is a vector, so it has both magnitude and direction is always given by the unit vector. Number 4, once again, we've got exactly like number 3, given a magnitude of 36 kilonewton force, and we're supposed to determine the force F. And now the direction is given by the unit vector, where we get it from vector AB. A, its initial point has been given, and B is the terminal point. So now, once again, we have to find vector AB first, terminal point minus the initial point, and then we get our vector AB, and then calculate the unit vector. It's the vector divided by its length, and please check my calculations if you are going to get that length to be 9, and then thereafter multiply the given magnitude by the given or the calculated unit vector, and make sure that you get everything correct. Don't forget the units. Here are some examples, number 5 and number 6. Once again, number 5 follows the same route as number 3 and number 4, but then we get to number 6. Number 6 has got how many forces? 4 forces. The first force, F1, is given, but F2, you are given the magnitude and you are told the direction, that it is in the direction of that vector. So you have to first calculate the unit vector that gives the direction to F2. Also for F3, you have to calculate the unit vector that gives it its direction. F4, exactly the same. Then in F2, F3, and F4, multiply by the given magnitude to get the forces. Remember, in number 6, you are asked to find the resultant force. That means F is equal to F1 plus F2 plus F3 plus F4. When you're doing your addition, you add the corresponding components. So that means you'll have the sum of the x components of all 4 forces times I plus the sum of the y components of all forces times j plus the sum of all 4 z components for times k. Number 7, A, B, and C have been given with their coordinates. Forces FAB and FAC, you've been told how their direction should be calculated, and please determine a resultant of those two forces. And remember, it's not just the force F, but you need to also calculate its magnitude. Then we move on to the scalar product, which is also known as the dot product. The scalar product of two vectors, u and v, with components u1, u2, and v1, v2, is given by multiplying the corresponding components and add those products. So that means it's u1, v1 plus u2, v2. So you multiply the corresponding components and you add those products. That gives you the dot product of the given two vectors. Now let's go to some examples. We've been given u to be I plus root 3j, and v is negative root 3I plus j. To get the dot product, you multiply the corresponding x components. So it's 1 times negative square root of 3 plus the y component, square root of 3 times 1. And then you add and you get a 0. Then we go to number 2. Number 2, we have been given u to be 2I plus j and v 3I minus 2j. Once again, multiply the corresponding components, so it's 2 times 3 plus 1 times negative 2. Same as number 3. Here are some properties of the scalar product that will be useful as we move forward. U dot v is the same as v dot u, or equivalent or equal. Please note, when you multiply one of those two vectors with a scalar, it's the same as just multiplying the scalar to the dot product. Number 3, note that you can distribute the dot product inside the bracket. Number 4, the length squared of a vector is similar to u dot u. That means the vector dot itself. Number 5, the angle between two vectors can be calculated using that formula u dot v, all divided by the length of u, length of v. And then number 6, for orthogonality or perpendicularity as it's usually known, but we'll stick with orthogonal. In order for u and v to be orthogonal, their dot product must be equal to 0. Remember, orthogonal, perpendicular, the angle between them is 90 degrees and cos 90 is 0. Also note, you will only get a dot product of a vector with itself to be 0 if that vector is a 0 vector and there is no other condition. Examples. In number 1, we're asked to find the scalar product between those two vectors, and the angle between them has been given. So that means we're using the formula cos theta is equal to u dot v divided by the length of u times the length of v. Now we've been asked to find the scalar product or the dot product. So that means u dot v is equal to the length of u, length of v, cross cos theta. And then we do the calculations and check whether the answer should be 2. Number 2, we've been given u, v, and w. Firstly, let's find u dot v. We know we'll multiply 2 and 5. Add that to -2 times 8 and get an answer. And then for b, it's the answer for a multiplied to the vector w. Note that this is just a scalar multiplication because u dot v gives you a scalar. So you get a number in a, take that number, multiply it to w. That means each of those components will be multiplied by that scalar. C, the length of w squared is just equal to w dot w. So find w dot w and see what you get. Also for D, v minus 2w. First evaluate that v minus 2w, get that answer, and then find the dot product between that answer and u, and you'll be able to get the correct value for that dot product. We go to number 3. Now here we are supposed to find the value for k. For a, the condition is that p and q are orthogonal. Here is the solution. P dot q must be equal to 0 because we are told that they are orthogonal. Then the dot product gives us 6 plus 5k equal to 0. That means 2 times 3 plus k times 5. And then we solve for the value of k. Now, when you get to b, the angle between p and q is given to be pi over 3. Once you are given an angle, then that means the formula that we use is cos theta equal to u dot v divided by the length of the first vector u times the second vector v. In this case, we have p and q. So here's the solution for b. P dot q, we had already solved it in a, we got 6 plus 5k. And then divided by the length of p times the length of q. On the left hand side, the value for theta, we know it's pi over 3. And then these are the evaluations that I did. I took the denominator on the left, on the right hand side to the left, and then thereafter squared everything up so that I get rid of the square root signs, and then evaluated. Please check, and on your calculator use mode equations. This will be the correct solution. That's what we get even from using our mathematical software, Mathematica, as well as MATLAB. C, the angle has been given to be pi over 4, so you go through the same route as B and fill in the missing spaces and give us the final quadratic equation as well as the values for K. And then we come to the applications of the scalar product. Firstly, going straight to mechanics, we've been given acceleration and velocity. Note that they are both vectors. You are asked to find the angle between them. So what do you do? Cos theta is equal to v dot a divided by the length of v times the length of a, and then do your calculations and give us the value for theta. The second one is where we are able to calculate the work done using the formula F dot R. And it is the work done by a force to move a particle through a displacement vector, which is R. Remember that you may not be given the direction of the force, so you might be able to calculate it. So use this formula to calculate work done for 2A and 2B. Both the force and the displacement have been given. In some books, they don't use R, they use S. And in some books, they use capital letter D. So don't be confused by that. And then let's look at C. F is supposed to move an object from point A to point B. So it means you need to determine that displacement. That displacement is just vector AB. Vector AB will be the terminal point minus the initial point. Once you get vector AB, that will be your vector R. Then you do the dot product between F and R. Now, one other thing that we need to recall, that we are able to find the derivatives of vectors. As in mechanics, we know if we have the displacement, which is R or S in some cases, the velocity is the rate of change of displacement, and we write it as dr over dt. And acceleration is the rate of change of velocity, which is dv over dt, which means it's the second derivative of r with respect to time. So acceleration is dv over dt, and v is dr over dt. So note that you will only be able to do that when your x components of the displacement are given as with variable t, and y also with variable t, as we have in number 3. X component is t to the power 4 minus 3t cubed, and the y component is 6t squared minus 2t. Firstly, we're supposed to calculate the velocity, which is dr over dt. So all you do is to differentiate the x components and the y component. And please don't forget, when you write your v, it must have I and j, because they are still forces of vectors. And then we come to acceleration, to the second derivative of r, which is the first derivative of your velocity. And then the next thing we've been asked to do is to find the angle between our velocity and acceleration after 1 second. So please attempt this and see. Let's see what we'll get. Then we move on to calculating components. We are able to find the component of one vector along another. So if in this case we have the component of u along v, then the formula is taken directly from the formula for the angle between two vectors. Hope you still remember that it's cos theta equal to u dot v divided by length of u times length of v. But then if you want the component of u along v, then you only use the right hand side, which is u dot v divided by the length of v. And note that theta is the angle between u and v. Let's do just one example and a few exercises. Number 1, we are asked to determine the component of u along v. And we've been given both u and v. We write down the formula. We know that it will be u dot v divided by the length of v. The dot product between two vectors, we know it will be their x components, the product of their x components plus the products of their y components divided by the length of v. And that's our answer. Please attempt to do number 2 and number 3. Just u dot v divided by the length of v gives you the component of u along v.